Okay, I'm going to go ahead and draw some things on here for a line. A line has 2 arrows on both sides. Your line segment is ended with 2 little dots there. And a ray has a point on one side and continues forever on the other side. Okay? An angle is made up of 2 rays put together, shared at that vertex. So, difference between all these angles, acute angles are less than what? 90 degrees. So this is less than 90 degrees if it's an acute angle. Okay. A right angle, pretty straightforward, has to be what degrees? 90 degrees. An obtuse angle has to be greater than 90 and less than 180. And then a straight angle would be what? 180 degrees. It's literally just a straight line, so 180 degrees. Okay? So kind of a refresher on some of that vocab there. Next, 2 pictures here. There is a relationship between the 2 angles that share a side. So for this one here, I've got 6M and 3M, and they share this side angle here, or this ray, I should say. We call this complementary angles. Okay, so if I asked you, I have 2 angles, one of them is 20 degrees, and they are complementary, what would you tell me the other angle would be? If one of them is 20, the other one would have to be 70, right? So complementary add to 90 degrees. That is something else that you will need to know in order to answer some of the questions on your homework. But if I was just solving this, that's just a quick little math one-step equation. Add these together, I get 9m is equal to 90 degrees. So my m value is equal to 10. Okay, if we call these complementary angles, what would I call these 2 angles that are next to each other that form a straight line? What did you say? Supplementary. I thought you said summer for a second. Yes, supplementary angles. Supplementary angles add up to 180 degrees. Okay, if I add these together here, I get 10K is equal to 180. So what is K going to equal? 18. Okay? So hopefully you feel pretty good about that stuff. That's, again, just kind of a quick refresher from geometry. Okay? Now, this next part gets a little confusing just in the sense of how the notation is. Okay? In your geometry classes, I know I did it, I know Mr. Lortzen did it, I'm pretty sure Mr. Butler did it, but we kind of did some practice problems of, like, if I asked you what the degree angle is between, let's say, like, 6 o'clock, right? The degree between those 2 hands would be what? 180 degrees, okay? Now, between if I had at 12 and 5, if I had exactly at 5 o'clock, we think about each of these little sections here, right? There's technically 3 sections, yes? Of like 1, 2, 3. That would add up to this thing right here being 90 degrees, right? So each section, each kind of 5-minute interval there would be a total of 30 degrees, right? So if I wanted to know what the degree is between the 12 and the 5, or the minute and the hour hand there, I would just add all these 30s together, and this would be a total of 120 degrees. Does that make sense? Okay. Now, basically, what we're going to talk about here is if you have a fraction of a degree, okay, there's a more precise way to give it, and that is in terms of minutes and seconds, which is kind of confusing. So I'm going to draw like a real zoomed in section here, okay? So a circle has how many degrees? 360 degrees, right? There are 360 degrees in this circle, okay? Now, there's how many minutes in an hour? How many minutes in an hour? 60 minutes in an hour, right?
That's right.
So I go all the way around, and that's 60 minutes, right? Now, 1 minute is not 1 degree. That's the tricky piece, okay? if this was one really tiny, I'm not going to draw it that small because otherwise you won't be able to see it, but let's pretend that this is 1 degree. Okay? Technically, there are 360 of these all the way around the circle, yes? Okay? So 1 degree is not 1 minute. That wouldn't make sense because you just told me that there's only 60 minutes, right? In an hour. Okay? So within, and this is where it gets confusing, within this 1 degree, there are a total of 60 minutes. Which is confusing. Don't think about a clock, okay? Think about 1 degree. If we want to label it down even closer, even smaller, we're going to say that in between here is going to be 60 minutes. Okay? And then if I broke it down even smaller and I looked at just 1 minute here, within that, there are going to be 60 seconds in 1 minute. Which again is confusing when you think about a clock versus the degrees. So in general, your kind of breakdown is that degrees are the first kind of rule of thumb for labeling like the precision, right? The degree is the biggest thing. And then it goes minutes, and then it goes seconds, okay? But don't think about a clock specifically because then that's going to confuse you in the terms of degrees and stuff. So 1 minute, like I just said, there are 60 minutes in 1 degree. So 1 minute is 1/60th of a degree. Okay, does that make sense in terms of the picture I have here? Right? 1 minute, one really, really small little piece of this, right? 1 out of 60 of those is going to be your minute, okay, out of the degree. Now a second, 1 second is 1/60th of a minute, which we denote with 1 and then the little apostrophe there, double apostrophe I should say. And that is your 1 second notation, okay? Minute notation has 1 apostrophe, second notation has 2 apostrophes. So this is our degree, minute, and second notation for giving a fraction of a degree, okay? So this 42 minutes and 38 seconds is part of a degree, okay? The way that I kind of like to think about it, I'm just going to write DMS because that's what degree, minute, second stand for. If you ever see that notation, that's what that means, is I want you to write it in degrees, minutes, and seconds notation. But basically, 60 minutes is going to add 1 to your degree, whereas 60 seconds is going to add 1 minute to your notation, okay? Does that kind of make sense a little bit?
No.
The good news is here, you don't really have to understand like the why behind it, but you do need to be able to use your calculator to solve it, okay? So for these 2 examples here, I'm going to kind of show you by hand how we would do these, but then again, I am going to show you how to do it on the calculator, which is what I would suggest doing on your homework, on your test, on your quizzes, and all that kind of stuff, okay? You will never have to do this without one of them. So if I have 51 degrees, 29 minutes is how I would read that, 32 degrees and 46 minutes. If I add these 2 together back in like elementary school, let's line these things up here. Starting on the very far right-hand side, we got to make sure to carry our ones. So 9 plus 6, that's going to give me 15, and that's going to give me 7, so 75 minutes. And then I'm going to have 83 degrees. If I have more than 60 minutes, I can add 1 to my degrees and then subtract 60 from my minutes. Okay, so this is the same thing as 84 degrees because I'm subtracting 60 to this and adding 1 to this. And then I'm going to have 15 minutes left over. So it'd be 84 degrees, 15 minutes is that answer to this problem. Okay, I'll show you how to use the calculator here in a second. Let's look at the next one. The next one's subtraction. So with subtraction, we are going to have to borrow things. When we are subtracting, that is when it gets a little tricky because I am taking a part of a fraction of a degree, so we have to be really careful when we're subtracting. So I've got 90 minus 73 degrees, 12 minutes. Well, if I just wrote 90 minus 73 degrees and 12 minutes, do I have anything to subtract from the 12 minutes? I just have 0 here, right? So I'm going to need to borrow one from the 90 degrees and make it 89 degrees. And then how many minutes am I going to have? 60. So it's going to be 89 degrees, 60 minutes, minus 73 degrees and 12 minutes. Okay, then we can subtract again from right to left here. 60 minus the 12, that's going to give me 48. And then 89 minus 73, that's going to give me 16. So 16 degrees and 48 minutes, or it's really, really close to 17, but not quite 17 degrees. Okay, there's another notation that we use, and that's just using decimals actually. And again, the calculator is going to be really helpful for that. Okay, so now grab your calculators out. If you don't have one, go grab one from me. So on your calculator, in order to write this exact thing, you are going to type 51, and then you're going to hit second apps, and then it's going to pull up a menu with degrees and minute symbols, okay? So you can type that in just as you see it. So you'll do 51 degrees, 29 minutes, and then add the 32 degrees, 46 minutes. Just kind of a lot of button clicking there. And you should get the 84 degrees, 15 minutes. So I'm going to give you, actually, I think you get it as a decimal. So I'll give you a minute, type it in. We'll see what you get, and then I'll help you get to the action or answer in the format that I want. So on your calculator, you got 84.25. That's as a decimal. What the fraction, or sorry, as like this is 84.25 degrees, right? Which if you think about a clock, if I asked you 1/4 of a clock is how many minutes, is technically 15 minutes, right? So that's kind of where that comes from there. So in your calculator now, you're going to type in second apps, but you're going to choose the option 4 that has a little caret with a DMS option. That's going to change it into the degree, minute, seconds notation to give you the answer that it's asking for. Awesome. Okay, so then try out the second one and see if you get the same thing. Again, same thing, you're just going to hit subtract instead. You don't have to do any of the borrowing because the calculator is smart enough and it'll do it for you, but you will have to change it into the DMS option by choosing option 4 there. Okay. All right, so you can use your calculators for those. Now we're going to convert this to decimals, okay? Now, if you notice underneath the second apps option, there is not a double quotation mark there. Why? I don't know why they didn't put it there. The only place that you can go to get this little symbol is by clicking second. No, I lied. It's alpha. Sorry. Alpha plus. It's right above the plus sign. Why is it not in the angle menu? I don't know, but it is underneath or above the plus sign. Okay, so on your calculator, you can literally type this exact thing in, 74 degrees, 8 minutes, 14 seconds. And when you type this in, you should end up getting 74.137 approximately degrees, okay? Now, I am going to show you how to do it by hand really quick. Again, you can use your calculator though, so you don't really need to do it by hand, but I just want to show you where this stuff is coming from. So this 74 degrees would stay there for your answer, but then it is 8 minutes. And remember, a minute, right? Sorry, what am I trying to say? 1 minute is 1/60th of a degree. So this would be, we're adding 1/60th times my 8 minutes. That's like the decimal part of the degree. And then for a second, Well, if I change it to a minute first, that's 1/60th, and then a second would be another 1/60th. So then in total, multiply that by 14, that's how many seconds it is as a decimal. And if you type this whole thing in the calculator, you're also going to end up getting the same answer. So that's kind of how you do it by hand. But again, all you need to do is be able to do it on the calculator. Okay? All right. And then we're going to go backwards. We're going to convert 34.817 to degrees, minutes, and seconds. So on your calculator, go ahead and type in 34.817. And then you'll type second apps. And you're going to go to option DMS. And it will give you your answer as 34 degrees, 49 minutes, and 1.2 seconds. That's fine. Okay, so in order to change this into degrees, minutes, and seconds by hand, if you wanted to, again, you don't have to, but this 34 degrees is obviously going to stay the same, but this 0.187, I'm going to multiply by 60. When I multiply it by 60, I get 49.02. So that changes that to minutes. So now, right now, our answer is 34 degrees, 49 minutes. Actually, 49.02 minutes. But I want to change this into seconds. So I'm going to multiply that by 60. So I get 34 degrees, 49 minutes, and then plus 0.02 times 60 seconds to give you your answer of 34 degrees, 49 minutes, and 1.2 seconds. Okay, again, that's doing it by hand. You don't have to do it by hand. You can just plug it into the calculator. Okay, but that is kind of the why behind the answer. Any questions on converting between those two? How do you plug just this part in the calculator? Yeah, so just type 34.817, and then you'll do this little symbol, the DMS, underneath option second apps, and then just hit enter, and it should take it to the degrees, minute, second answer.
Oh, now it's...
Oh, okay. Good. All right, next page. Okay. All right, again, a few more definitions here. So, we got a coordinate plane, okay? We're going to see a lot of these with some circles on it. But the standard position for an angle is an angle that is starting at the origin, okay? So right here, I'm going to do different side color. Its initial side is going to be on the x-axis. So this right here is always where we start our angles. This is our initial side. And then where we end is what we call our terminal side. So like, let's say we ended right here, okay? This would be my terminal, wow, I can't spell, terminal side, okay? A few other kind of quick things about, oh, and then the obvious angle would be in between those two. Just some other kind of vocabulary about a coordinate plane. We have different quadrants, right? This would be quadrant 1, and then we go counterclockwise. So quadrant 2, quadrant 3, quadrant 4. Or fun fact, if you connect all of them, the coordinate plane, mark it with a C. Okay, so if I asked, like, for example, what quadrant is 181 degrees in? Where is 180 degrees? Yeah, it'd be on a straight line technically, right? So like 180 degrees would get you here. So then 181 degrees would just be a little bit past that, right? So 181 degrees would be in quadrant 3, okay? We understand that each quadrant is 90 degrees, yes? 90, 90, 90, 90 adds up to a total of 360, okay? So this will come in very handy while we talk unit circle stuff, okay? Now, coterminal angles are angles that differ by a multiple of 360, okay? If I went and I said, okay, this angle of, let's just call this 45 degrees, okay? That's 45 degrees, but if I go all the way around the circle and then back to that same spot, isn't that still a difference of 45 degrees between the initial side being that positive x-axis and where it ends? Yeah, it's still technically the same angle, right? It just went around again. So you could write this as 45 plus, for another coterminal angle, we're adding 360. But I could add a total of 360 degrees however many times we wanted to. So this expression right here, 45 plus 360 times the number of times you go around the circle, would give you that same angle every single time, okay? There will be a question similar to this on your homework, which is why I'm going to point it out, because the notation is a little confusing, but if it's a degree, you're adding 360 times the number of times you go around, okay? Because you can change that anytime. So the question asks us to find the smallest possible positive measure coterminal with each angle. Okay, so I've got 908 degrees. How many times am I going to go around the circle if I have 908 degrees? Yeah, let's subtract 360, right, until we get a smaller angle that is still positive. Okay, so let's find how many times around can I go and still be positive. So minus 360, that gives me 548, minus 360 again, that gives me 188. Okay, so 188 degrees is the smallest positive measure that is coterminal with that angle of 908. Okay? Okay, negative 75 degrees. I want a positive value. If technically I was drawing this on my circle here, negative 75 degrees would just be down in quadrant 4, 75 degrees.
But we don't like that because it's not positive.
Correct. We like positive things. So we're going to add 360 until we get a positive number, which won't be very many this time. Just add 360, and that's going to give me 285 degrees.
So you always want them to be.
Okay, negative 800, again, we're just going to add 360 until we get a positive value. So if I add 360, what do I get? 440. And then, oh, but it's negative, and I add 360 again. What do I get? Negative 80. So close. Add 360 again, and I get 280 degrees. Okay, so again, that negative 800 is saying that I'm going around this circle 1, 2, 3 times, and then going another 80 degrees, okay, which would be the same thing as if I just went around 280 degrees. They'd be in the same spot, right? Okay, now, radians versus degrees. In physics, you guys use degrees, yes? Yes, I think. I think you guys use degrees in physics. So if you're also taking physics, you are going to want to be very cautious of what mode you're in, especially this semester, because we're going to be a lot of the times in radians. And then when you go to physics class, you're going to want to be in degrees. So be careful with your mode. If you get a different answer in here or there, it's probably because you're in a wrong mode, okay? So radians are just another way of measuring degrees. They're a little easier to work with when we start talking about trig functions, meaning like sine, cosine, tangent, that kind of stuff, okay? So we're going to want to leave it in terms of pi if it says we want a radian, and we're going to change it from radians to degrees by multiplying by a fraction. So over here is a not quite complete unit circle, but it does have the degrees on there. So if you guys look here, all it is starting at 0 degrees, here's 30 degrees, 45, 60, 90, and then all the way around. There's those different degree measures, okay, which we're pretty familiar with, right? It's the radians that we aren't, excuse me, familiar with yet, okay? Excuse me. Okay, so 30 degrees is actually the same thing as pi over 6. 45 degrees is pi over 4, et cetera, et cetera. When you get over to 120, That's actually 2 pi over 3. Okay, how are they getting these numbers? There's obviously some sort of ratio going on. All the way over at 180, it's pi. So pi, in terms of degrees, is 180 degrees, okay? Pi, in terms of, like, evaluate pi, that's 3.1415, all this stuff, okay? But in terms of degrees, pi and 180 are the same. So to change between degrees and radians, we're either going to multiply by pi over 180, okay, to get a radian, or we're going to take and multiply 180 divided by pi to get something in degrees, okay? So what does that look like in an actual example? So we're going to convert each degree measure into a radian measure. So 45 degrees, we are going to multiply by pi over 180. Now, when we're changing from a degree to radians, very easy to remember. You always want pi in your answer at the top or at the end, so your pi should be on the top, okay? Now, when you're evaluating this on your calculator, I don't want you to type 45 times pi and then divide by 180. All I want you to do in your calculator is the 45 divided by 180 piece, okay? And then simplify that fraction, okay? So 45 divided by 180, I think that gives you 1/4 pi. Or you could write this as pi over 4. Okay, this is now the radian measure of 45 degrees. And I know it's in radians because there's one of two things. There is either a pi symbol, which is a pretty good giveaway that it's in radians, or there is no degree symbol. Okay, that's how you know it's in radians. Okay, next one. Negative 270, I'm going to multiply again by pi over 180. And all I want you to do in your calculator is plug in negative 270 divided by 180. And simplify that as a fraction. I don't want you to write them as decimals. As a fraction, you should get negative 3/2 simplified, or negative 3 pi over 2. Okay, if you can help not having decimals, don't have decimals. Obviously, this next one, are we going to have decimals? Yeah, because there's a decimal in the degree, right? So 249.8 times that by pi over 180. And again, all I want you to do in your calculator is plug in the 249.8 divided by 180. And you'll get approximately 1.39 pi. Technically, you could multiply it by pi, and that would be fine too. That would still be in radians. But again, it's going to be a lot easier to work in terms of pi. So try and get in the habit of leaving pi in your answer. Okay, going in the opposite direction. If we want to change something that's in radians to degrees, all we are going to do is multiply by the opposite. We're multiplying by 180 divided by pi. Do you even know why I can multiply by this?
Because you can eliminate.
Yeah, I can eliminate. But also, like 180 and pi, aren't those the same thing technically in terms of degrees versus radians? So really, all I'm multiplying this by is what? 1, technically, right? I'm not changing the value of this angle. I'm just changing it into a different mode or into a different, form of measure, okay? But yes, the pi's on the top and the bottom are going to cancel out, which is how I always remember to multiply by 180 over pi to change it back into a degree. And then for this one, you will have to, in fact, multiply 9 times 180 and divide that by 4. Okay, make sure order of operations, you're multiplying the entire top two things together before you divide by 4. And you should end up with an answer of 405 degrees. Now, just some kind of number sense. This should kind of make sense because 9 pi over 4 is really close to, obviously, 8 pi over 4. Well, what does 8 pi over 4 simplify to? 2 pi. If I go back and look at my circle up here, 2 pi would be where? 360 degrees. Okay, go ahead and write this on here. This is also 2 pi. Okay, so it makes sense that 9 pi over, 9 pi over 4 is going to be bigger than 360 degrees. Okay? Which I want to go back one more time also. When you were talking about coterminal angles, right? If I had, instead of 45, let's say I had pi over 4 as my angle, what would I add if it's in terms of radians to find another angle? Would I add 360 or would I add something else? Yeah, 2 pi, okay? So my coterminal angle would be 2 pi, but times n. I could go around as many times as I want, and as long as I go around a 2 pi total of times, I'm going to end up back at the same spot. Okay, so that's another way of writing it. Again, on your homework, there's one like that, so I wanted to make sure to kind of point that out. Okay, back to it here. Letter B, negative 5 pi over 6. Again, timesing that by 180 over pi, because I want those pi's to cancel out. Pi's go away. I need you to multiply across the top and divide by the denominator. My answer will be negative. That is okay. You should get negative 150 degrees. Now, last one is 4.25. How do I know that it's in radians and not degrees? There's no degree symbol, okay? So we can assume that this is in radians, and it also told us to change it into degrees, so that's how we can also know. But the hard part now is to remember, what do I multiply by? Because normally, I always say, well, multiply by, if there's pi up in the top here, we want pi to be in the bottom, right? But there's no pi symbol. So you just need to remember when you're changing from radians 2 degrees to multiply by the 180 over pi. However, you need to remember it. And now for this one, since I was given a decimal and I can't cross out any pi symbols, we are going to have to actually divide by pi. Don't divide by 3.14, divide actually by pi. So multiply across the top, divide by pi after you multiply it across the top, and we should approximately get 243.51 degrees. Okay. Now, for these problems, when you're just changing between degree and radians, you don't have to be in a certain mode. It shouldn't matter because you're just multiplying by pi over 180 or 180 over pi. Okay. So that won't matter, but be careful when you are on the previous page. I guess when you were subtracting, you had to either be in degree mode or have that kind of 0 minute option there. So just be careful there on the calculator, and be careful when you're going back and forth between pre-calc and physics. Today, not so much, but it will get more so where you're going to change between radians and degrees. Okay. Any questions over this stuff? Doing okay? Cool.